Start recording.
Do we know what we're going to talk about?
So,
Or we're just going to do whatever?
last time I was prepared to show Rholang in Rust. If you guys are interested in that, then I could still show that. It's kind of cool, but otherwise, I'm down for anything. Y'all have any preference?
I'm up for whatever.
I'm fine with Rholang.
Okay.
Is
Let's
it just
do-
us three that have...
Yeah, I guess so.
Yeah.
I don't want to waste it.
Wait,
Yeah.
exactly.
I know. Shane was the one that asked for this. And let me message him.
Oh, for Rholang.
Yeah. I'll start, and we'll see if he comes in or not. Let's see.
Would y'all be interested in one regarding microservices?
Sorry, I didn't hear that.
Would y'all be interested if I do a session in microservices at one point?
Oh, totally, dude.
Okay. Yeah, because I mean, that's something at work, right? So it's easier for me to do that.
Yeah. Yeah, that would be awesome. I would love to get like a good understanding of microservices, because
Yeah.
yeah.
There's so much more to it versus like I feel like when you and me like have one school, like, we just make a joke over microservices. I don't know. At least I used to.
Mhm. Yeah, it's like a
More to it.
buzzword.
Now you've seen the light.
Yeah. Good and bad.
Okay, let me see. Rusty Rholang, that's the name of the project. And I'm a little rusty because it's been a minute since I've opened this up, but let's see what we got. So I'll start with a Rholang program. So this is
Wait. Can you just give me a quick background? Because honestly, I don't know about Rholang.
yeah.
It's
So
like-
Rholang is the language that our chain uses, which is like a blockchain / cryptocurrency, you know, all that. It's the language they use for smart contracts. It's their own language that they designed, and it has a really interesting feature that it's not functional, it's not imperative. It's based on the process calculus, which is basically a way to think about computing where the only computation that happens is a communication between a send process and a receive process. It starts to sound like Elixir a little bit, but it is different.
Because it's focused, you're forced to only think of sending and receiving, I guess, is what you're saying? Like everything.
Yeah, I'm trying to remember now. I looked it up after your session, Dave. But it's something about, like, Rholang has two concepts in the entire language. It has a concept of a process and a channel. And
Okay.
so processes are sent on channels, or channels are sent on channels, I guess. But yeah, so that already is a little bit different than the Elixir architecture, where you kind of have like a process and things are sent between processes directly to other processes. Instead, we're
Just
sending
we-
we're just sending things on a channel or listening on a channel. You can't say I'm going to listen to this process. You can only say I'm going to listen on this channel.
Okay.
But yeah, so like the language is very like elegant and simple, but it can be complex to reason about. But the benefit of it is that they've created this blockchain that just by the design of the smart contract language, the entire blockchain is partially ordered, and so you get amazing speed ups around the like consensus algorithm. So like, for instance, if you know somebody's doing transactions in Korea with CryptoKitties and someone else is doing a transaction in Texas, there's no reason to reach consensus over which one happened first, which of those transactions happened first. And in some platforms like Ethereum, they'll have a concept of sharding, and there might be a Korean shard or a US shard or something. But in Rholang, there's no need for any concept of a shard. You only have to order transactions that are necessarily sequential, like one after the other, like one depends on the other. And that dependency can be shown as part of Rholang. Like the language itself defines the ordering of the transactions. And so you get this awesome feature where the architecture of the entire blockchain is reflected in the smart contract language. And you get all these cool features. But that's the big idea. Let me just show some of this though. Specifically, I mean, I wrote it in Rust, and so it can be interesting to see like writing a programming language and some of the design decisions. Oh yeah, that's Joshy. Where have you seen that before, Edmund?
Google. I just googled Rholang and then I like found the thing. They have a nice cheat sheet though. Have you seen this?
Yeah, Joshy's he does Rholang's office hours every Monday and Wednesday, I think.
That's cool.
In another Discord if you ever want to hop on those. But
who was the
Do you
guy
create it,
who
or is
posted
it
a
just like
video?
someone who? I'm sorry. You go.
Who was the guy you posted a video of last time that you were on a call with? Wasn't it Arching people?
yeah, it probably was. I don't remember specifically which video, but it's very likely Joshua was in that.
Yeah.
Yeah, I mean, yeah, if y'all are interested, there's the R-Chain collab over here. I can just show it. So they have a consensus collab. Every Friday we meet and talk about consensus algorithms for an hour. And then we have a computational calculus hour. There's a substrate hour. So there's like a ton of different things. And then on weekends there's a new one, which is Idris dependent types. So you can learn about that from some really smart dude. I don't know exactly who he is, but yeah, just all kinds of cool stuff. Okay, so anyways, Rholang. Let's see. Alright, so we've got a contract. And this contract is going to take in two channels, C1 and C2. And then it's this for is basically a listen. This syntax right here means listen on channel 1 and listen for an X. X can be whatever. In fact, you can even do pattern matching, but X is like the most generic variable. So listen on channel 1 for X, and then this bang right here means send. So the for means receive, and the bang means send, and that's really the only two like operations in the language. So it says, listen on channel 1. When we receive something, call it X, and then send on this other channel called somewhere else. Send X times 2, and then this really weird dereference operator. That's what this is right here. It's just like a pointer, kind of, but it's weird because it's dereferencing a channel into a process, because channels and processes are actually the same thing. But I won't get into that yet because that's like a whole rabbit hole. But if you just take away the dereferences for now, then we can just consider like this. You're listening on channel 1 for something. We'll call that something X. Then you send on another channel somewhere else. You send X times 2. So you send whatever you received, you multiply by 2, and you send it on another channel. And then down here we have this pipe, which means par for parallel. So it means in parallel to this thing, you also want to listen on channel 2 for some Y, and then send on the same somewhere else channel Y plus 5. Does that kind of make sense?
So how do they differentiate between X and Y?
Yeah, so that really gets to the base of it. Because these are in parallel, there's really no way to have some deterministic way of deciding like what you're gonna get here, like what X and what Y will be. More interestingly, like you could say like say they both listen on channel 1, then you don't know which of these two processes are going to receive the whatever goes on channel 1 first, you know? It could be either one. You just don't know. And that's kind of like the magic of it being parallel. And about like knowing what X and Y are, like this is just the most generic thing. This is just saying whenever you send anything on channel 2, I want to receive it and I want to call it Y. You could also do something more fancy like pattern matching. You could say some channel named hello was sent on channel 2, and this gets a little weird. This gets back into the reflective process versus channel thing. But you can pattern match specific stuff, and then you won't receive just anything on channel 2. You'll specifically receive some process that looks like this.
So only things that say hello.
Yeah, it's not a process that says hello. It's a channel called hello. Is what that would mean.
Okay, yeah, you're right.
Yeah.
Channel.
So what's the C2? Okay, so this is C2 is the channel 2.
Yeah, exactly.
Okay, so channel 2 is listening to channel Y.
No. It's we're listening on channel 2.
Okay.
And then whatever we receive is going to be something, and we're going to call it Y.
Oh, okay, I see. We're assigning it.
Yeah. So I mean,
How does it work? So could you change the Y to an X, or would that mess with it?
no, that's totally fine as long as you change it down here too.
Okay.
This X is just a substitution, so it's just like in a function, you know, like you can call it whatever you want in the parameter, and then its scope is only this for comprehension right here. So its scope is these brackets.
Okay.
Yeah. Okay. So yeah, that really gets down to the core of it. Let's look at some Rust code. Start with the main. Whoops. Okay, so yeah, basically what it's actually doing right now is it's taking that test.row file, or you know, some actual program from a file, and it's parsing it and then evaluating. The evaluation is right here. You know, that's kind of like running it in a virtual machine or whatever. So there's a concept of a tuple space, which is kind of like the space that you throw up all of your processes to. It's where processes live and wait for their match. So if you send something on a channel and no one's listening for it, it'll go into this tuple space and it'll just sit there until somebody else comes along and listens on that same channel, and then that'll cancel out the send and the receive, and something will happen.
So it's Tinder.
Yeah, basically, yeah, Rholang is just a giant Tinder for processes. So, yeah, let's see. So,
Wait, can you repeat that? So you said messages that are never listened to, or just a whole channel that's never been open to be listened to is put in there? Which of the two is it?
it can, wait, sorry, say the two again?
So there could be a case the channel was listened to for suppose a period of half an hour, and then after the half an hour it was stopped listened to, and their message is still sent on a channel. Does that go to the tuple space as well, or only if the channel was never listened to, then it's in that tuple space?
If there's something already in the tuple space, like if there's already a listen in the tuple space, and then you send a send, then it would go away. But there has to be a send and a receive on the same channel, otherwise it'll just sit there until it finds a match. And there's also, it's completely asynchronous, so there's no concept of like time or anything like that. Like if you look at the actual calculus that it's derived from, which is called the pi calculus, which is a process calculus. It's basically just the only reduction in the entire language is the comm event of a send and a receive together. So that's the only time anything changes in the actual language or in the actual like runtime, is when a send and a receive match on some channel. Otherwise, you're just waiting around and nothing can happen. So let's look at the tuple space. Tuple space is pretty simple. It's you got a hash map of sends and a hash map of receives. So the string is the channel name to a list of sends, basically. And this is a channel name to a list of receives. I before E except after C. Yeah. So this is just an easy way to index it. And getting into the specifics here, like, this shouldn't really be a vector. It's more like a set, because the things that sit inside a tuple space are not actually ordered. They're just kind of sitting there, and you can choose whichever one. So, like in the blockchain context, there's really no way to know which process is going to be picked up off a channel. So just to run through it really quick, like, we start with a totally empty tuple space, no sends, no receives, and then I spawn a process, or I spawned a send on channel X. And so in the tuple space, there's now, in the sends hash map, there's a value with a key that's X, and a value that's some other process or something. And that's what I'm sending. That's the message that I'm sending on this channel X. That's what the term is some other message. And so then somebody else comes along and they receive, they send a receive to the tuple space. And then instead of actually putting it into the tuple space, we can just say, oh, hey, there's actually a send on X and you're receiving on X. So let's actually just take the send on X out, and then let's grab the message that it gave us, and we'll run whatever the receive continuation is with that message. So in code, this looks like I'm sending, I'll do it like this. I'm sending on X, or on channel X, some message. I'll say nil, which is like the, base process, do nothing. And then in parallel, listen for some message on channel X. And then once we get that message, do something with it. Like maybe send it to Dave's inbox. Does that kind of make sense?
Yeah.
Yeah.
Okay. Cool. Well, yeah, so I mean, which part would y'all like to see then? Would y'all like to see like part of the evaluation of how like you actually evaluate, or would you rather see maybe like the parser or something? Or like which part of the language would y'all like to see?
I don't know, what do you find most interesting about it?
Yeah, it's all kind of interesting. It just kind of depends on where your interests lie. The parser right now is not that great. I can show you why. I'll show you my test.row program. So this is this is my program. It looks like a little bit different of a syntax. First of all, you'll notice that the par is actually wrapped in this par function. You see, it has these parentheses around it and par at the beginning, and then it actually separates them with the same par symbol. But the reason that I have this par at the beginning is because of something called left recursive parsing. Have either of you heard of this?
No.
We did in school, right?
Maybe, dude. Did you? I never got to it.
We did. I don't remember which class, but I definitely remember it. And what the name.
Dang. Well, I'm jealous because even if you don't remember
But
it,
I don't remember
you're probably
thing though.
yeah. It's basically just you fall into like a non-halting loop of recursion when something is left recursive, which means that like if I took out this par wrapper and then I tried to parse this whole program for the par term, then I would say, okay, well, what is a par? A par is a term followed by the pipe symbol followed by another term. And then I would say, okay, well, how do I know that this is a term? Well, I'll go into it and I'll say, well, first let me check what are the different types of terms. The first type of term is a par. So then I'll go in here and I'll see if this is a par. Well, actually, no. If that were a par,
Okay.
yeah, I'm not totally sure. You should be able to determine if this is not a par, right? I'm not.
This one explains it well. So basically, the par and the par the bar mean the same thing, right?
Yeah, exactly. For my
Okay,
code.
I'm following.
Yeah. So I do it like this. I can't actually explain left recursion right now. I'm forgetting what exactly it is that causes that loop to happen. But I basically temporarily fixed it until I get the LR parser down. And then the next change is that I use a question mark instead of that for comprehension syntax. So now it looks a lot more like a send. Here you have the send on Y, and here you have send on X. I mean, listen on X, and here's send on X.
Okay, so wait, what does the question mark mean?
Question mark is receive.
Okay, gotcha.
So this program is
Is that
basically
like part of the language, or is that something that you added in?
that's a change I made because I think the for comprehension syntax is like way too big. Like why make it so many symbols when all you're needing to do is.
Well, I don't understand. Yeah, I don't understand why you make it for also.
Yeah, I recently heard like why the designer made it the way he did. It's because he was like thinking of it like for comprehensions, which I guess they are, like in Python or something,
I don't know. I feel like it should have had, or like I understand it's like for this person, and I understand that also, or that was why I was thinking, but it just seems too similar to everything else of for that you used.
Yeah. I mean, there's no like loops in this language, but it's still it just seemed weird to me that the send was like so simple, and then the receive was just like big thing. So yeah, you can see here that the receive is actually, it looks a lot more like a function now. So you have the name of the channel, which is like the function name, then the input parameters, so it takes in something v, and then the scope of the function, which just sends v on y. And then in parallel, you're sending on x, you're sending nil on x. So this program basically sends and receives on x. This x will receive a nil. It'll call v that nil, and then it'll send nil on y. And if we run it, it should work. Fingers crossed.
go through these the Rholang by example?
I mean, I've been like talking with people that are, like the Rholang geniuses for a long time, and like still I barely understand the language. That's actually why I wanted to do this. Is to me, it's like the best way to learn the language, because writing it in the context of smart contracts is also kind of weird and like foreign to me. But something really interesting is happening with Rholang right now, where like people are realizing how powerful of a concept it is, and it's starting to branch out beyond just smart contracting language. People are realizing use cases for like graph querying and just like a whole bunch of different domains. And so I don't know, it's just a generally interesting way to think about programming.
Interesting.
Okay, so it failed to parse. Did I fuck something
Oh, that
up?
would be cool, like a GraphQL implementation in Rholang.
Yeah, but GraphQL cannot do what Rholang can actually do, because GraphQL, despite the fact that it's called GraphQL, can't do certain graph query operations. Like it's hard to express some like recursive queries that you might want to perform.
Like what?
So I mean, so first of all, like, do you know the like recursive example of like you have a table of managers and they have foreign keys to that same table recursively almost of who they manage or who their managers are. So it's like who you want to find the managers.
Yeah, no, I don't know that.
Yeah. Well, it's basically like you want to find the managers of all employees, but the managers are just foreign keys to the employee primary key. So they point to the same table. So you get this recursive call. And then say you want to be able to like run that operation a few times. You want to find out who the managers are. Then that becomes a very complex operation, which GraphQL can handle, but Rholang makes it really simple to reason about querying graphs just by like its nature of recursion. You can actually like express graphs in a different way than you normally would by like expressing the edges as variables and then basically running programs that evaluate queries. I don't fully understand it. It gets weird. Let's see. Why did this fail? Oh, that's weird. What is this doing here? Failed the parse program. Huh, why is it starting with a question mark? Oh, okay, so it's saying that it parsed the par. I have not solved the white space problem either. Dang. Well, I won't debug it right now, but I swear this is working last time. Let's look at something else. So, okay, here's another interesting thing. So the abstract syntax tree. So, you know, how you build like the intermediary representation after you parse, how you represent the language through its terms. The language only has a few terms. It has a par, receive, send, and a nil. So that's everything in the language. A par holds just two terms. It's like a tuple of two terms. And this is an enum. Are both of you, Dave, are you familiar with enums or the concept?
Yeah.
Yeah, cool. Yeah. So like, as an abstract syntax tree, this just means that.
Is anyone else getting a weird delay?
Yeah. It's me that gets delayed.
Oh, really? Huh. Can you hear me all right?
I don't know how to describe it without getting too far into the delay.
Wait, sorry, say that again?
Okay, so basically what's happening is I can hear you fine, but then I start talking, and then there's like a 5-second delay, and then I can hear myself talking.
Oh shit. Okay, let me put in headphones. Alright, try saying something now. Can you still hear yourself? Okay. Yeah, like every time I say something, there's like a long pause. But, oh man, this is weird. Dude, there's just like no good platforms out there except. Shit. Okay. This is so confusing, dude. I think we're like 10 seconds delayed or something. Okay. Yeah, I don't know, man. Okay. Yeah, let me try it. Yeah. What's up? Hey. Nice. Awesome. Okay. Man, I'm thinking about just like getting Zoom, like getting the $15 a month thing. Like, if even. Yeah, I asked him if he thought his pies could handle it, but he said they wouldn't. They wouldn't be able to. Yeah, he already has them. He already, yeah, he has them. Seriously? What? Holy hell! What the? Dude, that thing has to be able to handle some video chat. I'll get a Pi 4 and set it up. Yeah. Yeah. Yeah, that's actually a lot cheaper than Zoom. I don't know if the cheapest instance though could support video chat. Man, I can't believe it's so strong. Okay. So, yeah, sweet. This is gonna be so much better. Oh my god. Alright. So, the oh well, no, and I'm just saying with the audio. So, the abstract syntax tree, as I was saying, is that you just have a concept of a term, and this is how you define any. Oh shit. Got it. can see that. So, yeah, basically, whenever you want to define a programming language, I always start with the abstract syntax tree, which is pretty much always just going to be an enum of structs. Just some like what is a term? Like you have to define what an expression is in your language. Like what, it's almost like the base recursive thing, because when you evaluate the language, you're really just recursively looking for terms and then doing some kind of action based on whatever the term is. So in this case, you know what to do on a par. You evaluate the two subterms. You evaluate the left and you evaluate the right. You know what to do on a receive. You push the receive process onto the tuple space. And if there's a send, then you join them and do the continuation. Same on the send, and then the nil, you do nothing. And so from the simple data structure, then around it you can define all the different actions that your programming language does. So yeah, I define a tuple space to have a few operations like insert. You can insert a term into the tuple space, and I have this cool concept of just types. Because the send and receive are actual types in the language, you can reason about them. So you'll never accidentally send on a receive channel or something like that. You'll never put a send into the receive, and you can also pattern match processes based on whether they're a receive or a send, because we have them as types. So that's why I made these structs right here, like the send process, instead of doing something like send could have just been string, which is the channel name that I'm sending on, and the continuation, which is just another term. And box here means pointer. So I could have done this, but then I can't pattern match because it's just a variant of a term. So I can't say when it's a send, do this, or only, I can't write a function that only takes sends. I have to write a function that takes all terms. So in order to solve that, I made send its own structure so that it now has a type. And then I just wrap that type in a send variant. Let's see. So, yeah, I don't have to go into the evaluation and all that. This is the evaluating step. Basically, like on a send or a receive, you're going to first look. So like on a send, you're going to look on the receives. You're going to pop out that vector on whatever given channel the send is on, and you're going to take something if it's on there. But if there's nothing on that receives channel, then you're just going to insert the send into the tuple space. It's that simple. And then a par is just recursively evaluate the two sub-expressions. And a nil is absolutely nothing. Absolute unit. So there's also this really interesting idea. I showed this to somebody that has written Rholang 5 different times in Haskell through different iterations, and he told me that he used to write it this way, but he's actually started writing it in a new way that allows for beautiful recursion, and it's like a more functional way to do it, where the only reduction in the entire language is the par. That's the only time anything is ever evaluated, and there's only one COM event that even happens on a par. But what happens on the send and receive, you don't actually go into the tuple space like I'm doing here and modify it. Instead, all you do is when you want to send something, you pass that to a send function, with the send term and also some tuple space. And what the function returns is a new tuple space with that send on it. That's, like a functional way of doing it, right? Like you pass something in, you modify it, and you spit out a new version of it. But yeah, can you guys still hear me?
Yeah.
Okay, cool. Yeah, but basically he's just saying that you can build up a tuple space of sends and receives, and you can do a whole bunch of these and just keep passing back new tuple spaces, and you can build these tuple spaces up in parallel, almost like it's a whole bunch of different tuple spaces. Almost like you imagine the tuple space is like a dictionary, and then the par operation is the union operation on those dictionaries, or the merging of dictionaries. Just like you learn about the join function in school, on like how to merge two dictionaries. You can see sends and receives as functions that build up dictionaries, and then the par is just the merging of the dictionaries. So that's like the purely functional way to look at it, but also allows for a very easy parallelism. So yeah, that's pretty much all I want to show. Any thoughts on it?
Interested on how like the core functionality sensing the food, and you made the comment that outside of the scope of smart contracts, people saw value in it. Give some examples, maybe a little more detail into that if you knew them, where they found it.
Yeah,
That's what you understand.
yeah. So the process calculus itself, which is what this is, really very closely reflecting, is was originally designed for the telecom network, kind of like Rholang. Rholang is, I think, actually based on the process calculus. That idea of sending and receiving, but through channels. So it's actually a good model for like how you should describe an internet or some kind of web of communication. So it's really useful for describing highly parallel, highly distributed systems of communication in a very simple way. So that's why off the bat it makes sense to be used in a blockchain context, and then you can reach consensus over events that are ordered. Hello? Come in. Sorry, hold on 1 second. I think somebody's at my door. Oh, hey, you ready to go? Okay. 2 minutes. Hey. Shit. Yeah, it's my sister. I'm actually about to go get some Chian noodles. Yeah. Yeah, the whole like query processing thing is super interesting. I would love to learn more about it and then maybe try to bring it to you guys, but I don't understand it super well. But yeah, I don't know. There's a lot of use cases for it, and there's a lot of depth to it. What originally excited me about this language is if you ever want to learn like about how programming languages are implemented, this is like one of the simplest languages you could write. It's like easier to write than like Lua or something. So if you're ever just like feeling like writing a programming language, you can do this one, and it's parallel. It's got all these cool features. And yeah, if you ever hate your life. Well, cool. Thanks for letting me show it off. Yeah.
Hopefully Shane watches again now.
Yeah. Hopefully he'll be like, "What the fuck is this?" and have some questions. But, yeah. Cool.
Yeah.
All right. Yeah, sounds good. See y'all later. Bye.